So to follow the previous presentation on thinking about the facility and the OCP concepts, this presentation really focuses on a small part, just the electrical infrastructure, and comparing traditional designs to an OCP design. And we go through just an initial CapEx cost analysis of this. So, we first did this analysis 2 to 3 years ago. We refreshed it, looked again at the cost and stuff, and wanted to represent it. So if you think about just the Open Compute hardware and electrically, the big change is down at the rack level where you have a centralized power supply for the servers, and you can put a BBU right there in the rack, which gives you your UPS functionality, right? So if you're able to do that, what does the upstream architecture look like? And those are the questions we want to answer, and what's that cost savings that we get? How do you get N+1, 2N redundancy levels? And what if you have a mix of Open Compute and traditional loads in the same data center? How do you handle that? And can you still get some cost savings? So those are the questions that we're going to answer today. And the idea, and this is important for the foundation, is that we want to broaden adoption of Open Compute systems. Okay, so our goal here was to try to help facilitate that. So what we did is we analyzed capital costs only here, and we compared traditional Open Compute architectures. And we're just doing it from the medium voltage electrical all the way down through the power supply of the server in the cost analysis. And the costs are based on some of the ones that we know, well-known stuff in the industry. The models were done on a close to a 10 megawatt data center at an average kW per rack of 10 kW. And we did the cost normalized to euros per watt for audience. And this information is based on a white paper that we have. There's a few costs that we do have to update in the white paper, but that white paper 228 is already out. And as well as there's a trade-off tool where you can kind of compare architectures and take a look. So this is sort of the takeaway, but we'll go through how we got to this. So again, electrical infrastructure only, CapEx only, through the power supply. If you look at a traditional 2N data center, now this is cost per watt, assigned to cost per kilowatt, so divide by 1,000. Anyways, 2.52 euros. If you were to really slim things down and say, if I applied, super simplified electrical architecture in the vision of OCP, you could maybe get down to 146. But we think what might be pretty reasonable is the one on the right, which is 1.85. We'll show how we get there. So, and we'll talk sort of about tiers, but it's important to understand whether we talk, can we concurrently maintain this? Can you do your maintenance while the data center is operating? Things like that. Okay, so this is just an example of a typical 2N electrical architecture. And a lot of times you have cross ties to make sure you keep both sides up for maintenance. Sometimes you have multiple sets of breakers, input and output, load bank breakers, and this is sort of the example that I like the sign had, where you had a car with the extra wheels so that you can continue to go 240 kilometers per hour while you're still operating. And so the question we kind of asks is, Open Compute looked at server hardware and pulled out all the stuff that you really didn't need. What if you stripped out everything and had the bare minimum? What would that look like? So that's what we're kind of do. Now, you can question whether that's something you want to do, but what happens when you take all that extra stuff out that you might not need? And so it could look something like this. So it aligns with the simplicity and cost reduction mindset that Open Compute has. This is showing just one power path right to the servers. Get rid of the UPS, get rid of the cross ties, minimal breaker count, and all of them are optimized for their size and cost. So if you look all the way from the medium voltage LV pod level to the rack level. So what do you get in savings, and where do the savings come from? So we'll do a little waterfall. So on the left is what your euros per watt would be for the 2N data center. And you can get 42 CapEx savings here, right down to the $1.46. So big chunk of the savings is when you get rid of all that redundancy, and that kind of makes sense, right? The whole 1/2 that you have for the 2-in architecture. You do have to pay a little bit more for the rack system. And why would that be? Why would the rack cost more? It's got a bus bar in the back, right, which you might not have. Right, bus bar in the back. You get about an 8% savings from eliminating that centralized UPS. But there is a bit of a cost adder because lithium-ion batteries that you have in the rack do tend to be a little bit more expensive on a per watt basis. And you get a 10% savings from the consolidation of the server power supplies. And that's an important point. 2-in power supplies, generally oversized in each single server stacked up in a rack versus centralizing it in the rack in an N+1 fashion, okay? So that's where those savings can get down to that $1.46. Now, what if redundancy is still important and you want to be able to concurrently maintain? What would that architecture look like? So this is showing a 2-in architecture to a full open compute style data center. So it does reduce some of the complexity by getting rid of some of the cross ties, load breakers. There's no centralized UPS. PSUs are N+1 instead of 2-in, and which means you still need to trust some of the redundancy in the power supplies. And it's still significant savings, right? You still have 26% savings in this particular case. So you still get about 36 cents per watt by simplifying the 2-in design. And the rest of the stuff is kind of similar. A little bit, the rack system, you have a UPS savings, lithium-ion batteries a little bit more, and again, good savings in the power supply, both from reducing redundancy from 2-in and also reducing the oversizing. Now, make sure there are scenarios in open compute where some people actually continue to maintain 2-in power supplies. Instead of 2+1 or 5+1 power supplies in that shelf, they actually go full 2-in power supplies. That's something that I think Fidelity has deployed open compute, and I think that's something that they've decided to maintain. So what happens there? So the savings on the power supply isn't quite this good. So what happens is it ends up being an additional 13 cents to go full on 2-in power supplies with open compute. But overall, you still get a reasonable savings from $2.52 down to then $1.98. Okay, now, what if you do have a mix of traditional hardware as well as open compute? And this is how it's going to actually be as people start to adopt open compute. So there's a simplified 2-in, I think, and depending on the mix, you'll see that gray area, but we'll go through this. So still some savings because you'll have to maintain some centralized UPS. So the architecture, this is just an idea, an example of what it could be. So reasonably traditional, decide just to have centralized UPS N+1 on one side of the architecture. You still have some concurrent maintainability because you can still maintain both sides because you have 2-in power paths all the way down to each rack. And you can have a mix of traditional racks as well as open compute racks. Just in the case of the open compute, you don't have to have the lithium-ion batteries in the rack because you're still spending money upstream on centralized UPSs. So this is an example architecture where you still can save money in that facility and still deploy open compute, get some of those benefits, and have traditional gear. So, oh wow, I went crazy fast on these, so I can back up on that. But so so where some of this information is. So we've got reference designs that can be downloaded if you want to take a look at that. We have a specific one that kind of support open compute in this fashion, and so that URL, you can go look and browse some designs. We do have a trade-off tool, and we have two of them that are applicable. The one that applies to this particular study that we did is OCP versus traditional cost comparison tool. A little tool you can play around and look at pie charts and see where the savings are. We also look at lithium-ion versus VRLA TCO tool, because lithium-ion battery is both centralized as well as in the rack, is getting deployed in data centers now. It's growing very, very quickly, so you can understand the cost trade-offs of those. And then we have 2 white papers. The 228 supports this particular analysis, and another one is talking about lithium-ion batteries. So when we did this study, again, it was a couple of years ago. We were looking at the open compute architecture, understanding what really is the savings do you get. Again, this is electrical only. And we say, well, one, a lot can be saved by re-looking at that very complex 2N architecture and maybe simplifying that a bit. The savings in the power supplies for the server was a surprise for us. We didn't realize the amount of savings that you can get. And when you think about it, it makes sense. In a traditional server, you have a design engineer for that server choosing a power supply to make sure that it can handle the full load, the full load of what that server chassis could do, right? So he's going to make sure that he's not going to be underpowered, and he's going to put 2 of them in there. Open compute, it's at the rack level, so you aggregate that, and you can be N+1. And it's done at the operational level. The person operating the data center gets to make sure that you put in the right number of modules to power that rack. So the oversizing from the PSU is much, much less than that. Now, the cost of the rack-based PSU, if you look at just pure dollars per watt, is a little bit more expensive. But because of the savings from not oversizing, it's well worth it. And we think that a simplified 2N, and you can still, if you're trying to get open compute into an existing facility, you can still get a lot of the benefits of open compute, even though you still have maybe a centralized UPS there. And so those are the takeaways that we got from the study. And I'd like to open it up for some questions. The PDF that you download, we have some of our assumptions here on how we got the oversizing and where we got the money. So you can review that and either agree or disagree with how we did the study. What do you think? Think I went through the presentation too quickly? Yes.
Question on the unit you used for power, dollar per watt. Is that per year?
This is capital purchase, the purchase price.
That's a purchase.
Yes, so this is CapEx only. We did not go and look at OpEx. So when you look at OpEx, so later on in the rack and power, my colleague Liang, we did a study on 12 volts versus 48 volts PSUs, and to really understand the energy efficiency savings from that aspect. But we didn't go into, because where are you on that PSU efficiency curve? Are you way down in that 10%, running more like in the 80%, or are you more in the 94%? So there is going to be savings from reduced oversizing on the PSU for sure. Does anybody disagree with the numbers? Come on, there's a lot of smart people in this audience. Yeah. No? Makes sense?
About 0.01 negative.
Oh, yeah.
How do you get that negative?
Yeah, so when you look at the rack system, and you look at a standard old 19-inch rack, which everybody makes, versus the Open Compute 21-inch and the bus bar and stuff, there is a tiny bit, it is a little bit more expensive rack. A couple of reasons. There's a bus bar, and depending on the power, how big the bus bar is, and two, it's just the volume, right, is not there from a standardization perspective to have the cost come down. So it's a little bit more expensive, but it's a tiny bit. Useful information. So again, Stein looked at the whole data center. This is just a little electrical subsection of it. There's savings to be had. So, and a little bit about my background. I was Data center facility project lead for almost 2 years. Brevin took over. I'm still within the foundation as incubation committee. It's great. We're starting to get a good amount of activity within the data center facility project, but we think there's a lot of opportunities. So if there's anybody in here that works on the facility side that wants to either kick off a sub-project or has an idea or a question, that's what the community is for, to kind of work together and figure this stuff out. All right. Yeah.
The savings look impressive. Sorry. Yeah, the savings look impressive. How much impact of what's already in there in terms of raised flooring and all that sort of stuff? Does that, because, can you get rid of some of that stuff?
Yeah, so perfect example is the raised floor, and I didn't kind of cover that here on the electrical side. But when you look at the way as some of the hyperscalers are building facilities, get rid of the raised floor, flood the room with air, maybe through, fan wall type of thing, hot aisle containment and duct the hot air back. And so there can be a fair amount of savings by getting rid of the raised floor, especially since these racks are a lot heavier, and then you have to really think about how you design that raised floor. So that, I think there is other facility savings to be had. Yeah.
In which areas do you need help from the community for any of the projects that you guys are working on? How can we help?
Excellent. I'll maybe let Brevin answer that as the project lead. I mean, an active project right now is the modular data center one, which Roberto is leading. And again, the more participants we have to review and question and give input, that's great.
Yeah, Rob did a great job with Jason Schaefer to re-incubate the data center facility project. Right now, there are really 5 focus areas. There's mechanical, electrical, IT space and planning, monitoring and control, and telecommunications cabling. We want to make sure in the future to sort of separate those work streams so that we get the people focused on electrical or mechanical, get those committees together to really start to define some of those new standards that Stein mentions. So if you know anybody in your organizations that are maybe particular experts and you can point them towards Data Center Facility Group, we're going to start making those separations and getting those meetings and those committees together in order to, as I said, re-incubate the Data Center Facility Group and start to hopefully get the movement and savings that the other rack and power and server groups have gotten.
Yeah, and again, it's great. You're working with everything from end users to vendors to partners, So it's all a real friendly group. When usually people first bump in, they don't know if they can speak up or ask a question. There may be competitors on the line and things like that, but it ends up being good.
How often do you guys meet? And if somebody calls in and has comments, is it rude to provide feedback?
Yeah, so from the data center project has a regular monthly call. And then some projects, depending on where they are in the project phase, might have weekly. So the modular data center kind of has a weekly call with a core team to try to go through that. And no, everybody, I've worked in a couple of different committees, and everybody feels bad. Like maybe they didn't show up for a month or two, and then they pop in and all of a sudden start derailing the work that's been done. But generally, don't think of it that way, is usually any feedback is welcome because everybody wants a better product at the end of the day. So. Yeah, even if you haven't contributed, but you look at it, you say, yeah, I reviewed it, and you start poking a few holes in it, all good. All good. Right behind you, Brevin.
Okay, I was surprised about just 6% add for lithium ion. So 6% compared to VRI is not so much. So most of the times we're discussing much more, let's say, increasing cost for lithium ion.
Yeah.
And second question is, if you are, let's say, in local positions like Germany and you would like to have a TÜV certification, I know sometimes it's not allowed to have the batteries inside the white space. Is this something you even discussed that you have?
Fantastic question. So let's talk about two things with lithium ion, and actually we have to talk regionally. So something I had learned recently. So, and I can just go from kind of some experience from Schneider Electric's perspective. So 2 years ago, we launched a lithium ion solution for larger UPSs. So large lithium ion to replace large format VRLA batteries for UPSs. And people started to switch over when they knew that after that, the first battery replacement, you were better off. So the TCO was in a 5-year, because the lithium ion is going to last 10 VRLA, maybe 5 to 8 if you're lucky. But in the US, the value prop is better because for some reason, VRLA batteries are more expensive in the US than they are in Europe. Europe, it's not taking off as quickly because of the price difference, but they were 2x and the price keeps coming down. If you can believe it, depending on where the configuration, it all varies. There's some cases in the US where a lithium ion solution is the same price as a VRLA, if you can believe that. So it has rapidly become, it makes sense. Now, your second question is, so that's large format. Now, even if you compare lithium ion large format to putting little modules inside a rack, those are going to be a bit more expensive. There's more packaging. They're power batteries versus energy batteries, which is a little different. Energy batteries, car industry uses energy batteries and stuff like that. So these are a bit more expensive on a per watt basis. But it's going to be interesting with lithium ion in deployment like this. Especially Germany, I think, is the one country that stands out where they cannot be in the IT space. They have to be in a separate room. So we have to think about that and how do you get the most out of open compute. If you can't do that, can you put them in the back room? What's the right size and all that? And I think that's a important discussion to work out through the community. So, safety of the lithium ion is a big deal right now. The U.S. NFPA is coming out with installation standards, so we're going to have to see how that all plays out and if it's a big impact to this. Yeah. Oh, still. See, I went through my presentation quick so we can do all these questions. Good. All right. Thanks, everybody.